Hello, it is Miss Heaton signing in to talk with you about another method for solving for x when you are using ice charts with the KEQ equation to solve for equilibrium concentrations or for the value for x in those situations. This method is similar to the quadratic method, but it's great because you don't actually have to use the quadratic formula. It's a way to use your graphing calculator to figure it out. So you may want to make sure that you've got your graphing calculator handy. I'm going to turn on my virtual calculator, move it over here to the side, and clear it all so it is ready to go when we get to it. So the process here is to set up your ice chart and your KEQ equation just the way you've been doing. But then you're going to rearrange the KEQ equation so that it equals 0. You will then graph that equation and find the 0 point. So here's our example problem. I would like you to go ahead and try to set up your ice chart and KEQ equation, and then tune back in to check and make sure that you did it right. So for your KEQ, you should have products over, you know what? Let me give you a little hint here. HI is synthesized from hydrogen gas and iodine vapor. So that's from H2 and I2. Okay, so if you didn't try that before, or if you messed that up, go back and fix that. So your KEQ is going to be products over reactants, and it does need to be a balanced equation. So it'll be HI squared on top and H2 times I2 on bottom. And in your ice chart, you would have your equation H2 plus I2 in equilibrium with two HIs. And initially, you started with 0.5 of your HI, with 1 of your H2, and 5 of your I2. And so our change here will be minus x, and plus 2x. And for our equilibrium rows, we will come back and fill that in momentarily. So it'll be blank for now, but we know that it will be the sum of the I and the C rows. So our KEQ, we were told that the equilibrium constant was 100, and that equals products over reactants. So that'll be 0.5 plus 2x squared on top, and 1 minus x and 5 minus x on bottom. You would then want to expand this and figure out exactly what you've got on top and bottom. And it looks like we would have 0.25 plus 2x plus 4x squared on top. And in our denominator, it would be 5 minus x, 6x plus x squared. Then just like in the quadratic method, you're going to rearrange those equations so that you can tell exactly what is equal to 0. So this all equals 100. So what you'll do is you will multiply 100 by your denominator. So that will be 500 minus 600x plus 100x squared equals your numerator, 0.25 plus 2x plus 4x squared. And then you will move all of your terms to the same side so that you get 0 equals something. And when I did that, I got 96x squared minus 602x plus 499.75. So at this point, you could do the quadratic equation. You could do, here's your A, your B, and your C. However, your graphing calculator also has this great graphing feature. So pull out that calculator, and what you will do is you will put this into your y equals. Okay, so you type your equation into your y equals. You want to set your window, standard window is fine, negative 10 to 10 on both axes, and then you will graph it. And as you can see, mine is this parabola that you can't see the bottom of. These are the two axes. And so what you want to do is find the 0 value. And there's a way to do that by hitting second, calc, choosing 0, and then you want to set the left bound. And I'm at negative 0.6 right now. That should be plenty low. Actually, we could even move that up to 0. Then you want to go so that you are not quite to the second point. We want to first figure out the value of this point right here. So that's maybe between 0 and 2. So you'll make your x value about 2. And hit enter. The guess is about 2. That seems reasonable. It says our first 0 point is 0.984. So write that down. X could be 0.984, or pull up your calculator again, and let's see. You could also find the other 0 by again hitting second, calc, choosing the second one, 0, going over the left bound, maybe 1, 2, 3, 4 might be too much, maybe about 3, then going over again, the right bound, that looks like maybe about 6, so guess about 7, that's fine. And the other 0 is 5.28. Now obviously, you can't have an x value of 5.28 because if you started with 1 molarity, you subtracted 0.528 molarity, you'd end up with -4 molarity, so that's not going to happen. So that value we can discard. Instead, our x value will be 0.984, or here it says 0.985, so somewhere in that ballpark. So then for your equilibrium, you do 1 minus 0.984. That turns out to be 0.015, or 0.016, I guess, with our value, molarity of the H2. 5 minus 0.984 will turn out to be 4.016 molarity. I guess that was probably a sig fig issue, 3 sig figs. So 0.402 would be correct. And then for HI, it'll be 0.5 plus 2 times 0.984. And that should turn out to be about 2.47 molarity of your HI. So that's the graphing method. Again, that works best when you would have to use a quadratic, but you instead use your graphing calculator. This is Ms. Heaton signing out.